Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper CSIR National Eligibility Test July 2025. In this video, we discuss the solution of a problem from the section Real Analysis, and it is related to the pointwise and uniform convergence of sequence of functions. This question is placed in part B, which is a multiple choice question, and it carries 3 marks. The question ID is 562954101. Further, this question is suitable for all these examinations. Right. The given question is, for each n greater than or equal to 1, let Fn be a function from the closed interval 0, 1 to R, the set of real numbers, be defined as Fn of x is equal to nx if x belongs to the closed interval 0 to 1 by n. Fn of x is equal to 2 minus nx if x belongs to the semi-open interval 1 by n to 2 by n. It is open at 1 by n end, closed at 2 by n end. Fn of x is 0 if x belongs to the semi-open interval 2 by n, 1. Open at 2 by n end, closed at 1 end. Which of the following statements is true? We are given 4 options. The sequence Fn, n greater than or equal to 1, converges uniformly on the interval, closed interval 0, 1 to a continuous function f. Option 2. The sequence Fn converges pointwise on the closed interval 0, 1 to a discontinuous function f. Option 3. The sequence Fn converges pointwise on the closed interval 0 to 1 to a continuous function f. Option 4. The sequence Fn does not converge pointwise on the closed interval 0 to 1. Let's now discuss the solution of the problem in detail. Right. We have the sequence of functions fnx, where Fn is a function from the closed interval 0, 1 to R, real valued functions defined on 0, 1. For each n belongs to n, Fn is defined like this. Right. For x is equal to 0, we have, if you see x is equal to 0, it falls in under the first interval. Fn of x is nx, x is 0. Fn of 0 is 0. N times 0 is 0 for all n. Right. Therefore, limit extends to infinity of Fn at 0 is equal to 0. For x is equal to 1, it falls in the third interval, where Fn of x is 0. So, for x is equal to 1, we have Fn of 1 is 0 for all n. Right. And therefore, limit n tends to infinity of Fn of 1 is 0. Now we have to consider all elements x such that 0 less than x less than 1. That is, for any given x belongs to the open interval 0 to 1, there exists a natural number, capital N, such that nx is greater than 2. This is a Archimedean property of real numbers. This implies x is greater than 2 by n, small n, for all n greater than or equal to n. For all n greater than n, x greater than 2 by n. So, if x greater than 2 by n, it falls in the third interval, wherein fn of x is 0. So, fn of x for that x greater than 2 by n, fn of x will be 0 for all n greater than n. So, limit n tends to infinity of fn of x, where x belongs to the open interval 0 to 1 is 0, because it is a 0 sequence running for all x belongs to the open interval 0 to 1. Thus, combining all the three cases, we get the sequence fn converges pointwise, and the limit function is f of x is equal to 0 for all x belongs to the closed interval 0 to 1. Now, observe that f is continuous because f is a 0 function. For all x belongs to 0 to 1, f of x is 0. F is a continuous, it's a constant function. Every constant function is continuous. Right. Thus, what we have proved is the sequence fn, n greater than or equal to 1, converges pointwise on the interval, closed interval 0 to 1, to a continuous function f. Right. Let's look at our options. And our answer, what we have arrived here, appears against option 3. Therefore, option 3 is true. And in option 2, it converges pointwise to a discontinuous function f. But here, f is continuous. Therefore, option 2 is not true. In option 4, it says does not converge pointwise. It converges pointwise. That's what we have proved. Therefore, options 2 and 4 are not true. Option 3 is true. So, practically, this is the question that is placed in part B. Therefore, the question is over. Our answer is option 3 only. Anyway, we will discard the other option. That is uniform convergence. Yeah, that is the function. It is defined like this. Now, we recall a sequence of functions fn, n greater than or equal to 1, converges uniformly to a limit function f on the closed interval 0 to 1 if and only if mn tends to 0 as n tends to infinity, where mn is the supremum of mod of fnx minus f of x, where the supremum is taken over all x belongs to the closed interval 0 to 1. And we have f of x is 0. So this will reduce to, now mn is supremum of this. This is supremum of mod of fnx, x belongs to 0 to 1, because f of x is 0. Right. So let's see what will be the maximum values in these intervals. Let's see. Now, in the first interval, open closed interval 0 to 1 by n, fn of x is nx. It is an increasing function. The maximum is attained at the right end point of the interval, that is at 1 by n. Fn of 1 by n is n into x, x is 1 by n, that is 1. Right. In the second interval, in the open 1 by n to 2 by n closed, we have fnx is 2 minus nx here, and observe that this 2 minus nx is a decreasing function, So the maximum value in this interval is attained at the left end point, because it is decreasing left end point, that is at 1 by n. Fn of 1 by n is 2 minus n into 1 by n, that is 2 minus 1, that is equal to 1. So in the third interval, open 2 by n to 1, we have fnx is equal to 0. It's a constant function. The maximum value is 0 itself. Therefore, what will be mn? Mn is to be taken supremum of mod fnx. X belongs to 0 to 1. So, the maximum value in the first interval is 1. Second, it is 1. In the third, it is 0. Supremum for all x belongs to the closed interval 0 to 1 will be 1 only. So, that is the limit n tends, Mn is 1. Mn is 1. And as n tends to infinity, Mn tends to 1. So limit n tends to infinity of Mn is equal to 1, which is not 0. For uniform convergence, it is if and only if limit n tends to infinity of Mn is equal to 0. But it is not. Therefore, the sequence Fn does not converge uniformly on 0 to 1. Right. Let's look at our option 1. Fn converges uniformly on 0 to 1, whereas we have proved Fn does not converge uniformly on 0 to 1. So therefore, option 1 is not true. So combining all the options, we get the answer to this question is option 3. That is the detailed discussion of the solution of the problem from the section real analysis, which is related to pointwise and uniform convergence. And questions of this type are regular. Every time it is coming on pointwise and uniform convergence. And I see that this problem an easy one. Right. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I will meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.